10 frequently asked questions on air quality index. This is a support video to our working paper series, and the paper number is number 46, which talks about frequently asked questions on air quality index. What is air quality index? It's basically a simplified form of the information that we get on different pollutants based on their relationship to our human health, and presenting that same information, which is more scientific and complicated, as simple, using simple words like good, okay, moderate, severe. And the idea is that anybody with limited understanding of what pollutants cause, how much damage, at what level, should be able to see the color code and take necessary actions. So let's jump into the frequently asked questions. First one is, what is the difference between air quality and air quality index? Air quality is the amount of pollutant present in the unit volume of air. So this is what we breathe on a regular basis. This actually has a unit. For most of the time, aerosols, particles, they are represented as micrograms per meter cube, and the gases are usually represented as ppm and parts per million. And in case of air quality index, it's just an index value. It combines information on the units, pollutant severity to human health, and various other components, as we saw in the previous slide, and produces a simple index that one can understand what the air quality situation is at a particular time in that particular location. And it has no units. Is it better to report pollutant concentrations or pollutant AQI values? This entirely depends on who you're talking to. Let's say if you're talking to an academic person, that group will definitely want the actual value so that it can be used for some scientific analysis. If you look at a regulator, they will probably be in need of both the values, so that when the actual value itself, air quality value itself, can be used for regulatory purposes, and the index can be used for public relations and public awareness purposes. Non-governmental bodies, which are mostly in a bridge between regulators and the general public, they probably would prefer having an index value so that they can be immediately consumed and can be used for other activities. Similarly, you have other groups as well. For example, media, it's very important that we have simplified information for public relay, so they want index. If you're talking to parents, they want index because they don't want to go into the nitty-gritties of the science. And the industries, of course, because of the regulatory regime involved, they prefer to have a control of the actual value itself. So depending on who you're talking to, they would prefer information presented in different ways. So how is this AQI calculated? It's not a very complicated equation. It's a very simple equation. It's presented here, and it is something that can be translated into an Excel sheet for a quick demonstration as well. So what I will do is show you how it is how it uses Indian nomenclatures. This is the table for Indian air quality index calculations and how it is translated into an Excel file. Here, I'll give you a quick demonstration of how it is used. So let's say we have these 6 criteria pollutants, and we regularly get the concentrations from, these are daily average concentrations for each of these pollutants, and we want to translate that into an air quality index. And then you click on AQI, and it basically translates that into each of these numbers. So what we are seeing here is the conditional pollutant is PM2.5, which is a very high, 1400 micrograms per meter cube, and you get the highest AQI value already, that's 500. And the worst of the two is basically your PM10 and PM2.5, and that's average is 320. So different groups present this information in different ways. So either you can take the conditional pollutant and say that the air quality of the day is 500, or you can take the average of the two and say that, okay, today's representative air quality index is 319. And each of these color codes vary with the value itself that can be seen in the video, in the slide. And so we can change this value. Let's say ozone, it's a very nice and rainy day, and you have a very low concentrations. Let's say ozone goes to 40, PM2.5 goes to 40, PM2.5 is say 50, CO is 1000, SO2 comes to 30, and then this is 40. So we can recalculate and say that the conditional pollutant now is PM2.5, and the AQI is 67, and an average of the two worst pollutants is 58. The average of all is 49. So in this case, because all of them are really low and they're all in the same range, the using the average of all will also be okay, but it's not really advised to do so. So suddenly, if there's a dust storm, or if the dust storm passing, and then you have a different set of numbers coming in, then of course the equation immediately changes. The equation itself is not a complicated equation. It can be easily translated into Excel, and the example that is associated is linked in the video and also in the working paper. can be easily adapted to any other country's air quality index calculations. So every criteria pollutant has an index value, as you saw in the calculator. Then which one decides AQI of the day? So this is again is dependent on how each of the countries have defined their air quality standards. General way of doing it is to pick the worst of the all 6 criteria pollutants or an average of the 2 worst AQI values. What it does is when you do the average of the 2 worst, it ensures that interdependency of the pollutant health impacts are not undermined. So you're not putting too much emphasis on one pollutant, but and you're not neglecting the importance of the other pollutants. It's as we've seen in the Excel sheet, you can average all the pollutants as well, but it's not advised to use that as a representative air quality index because it will definitely undermine the severity of the worst pollutants of that day. What's the difference between Indian, Chinese, US, EU, and other air quality methodologies? There's a vast difference in how this index is used and calculated in different countries, and even the ranges that each of the different countries use to say when is the pollution severe. So it's a wide variety of it. So depending on what your country's standards are and what your countries or cities' background concentrations are, it will change your own standards, and automatically it will be reflected in your air quality index calculation. So it is very important that you pick a methodology which is suitable and more comfortable in reporting in your own city or country. How many monitors are required to calculate air quality index of a city? I mean, this is a big question that is often asked to get this. A scientific answer would be it's not, I mean, as many as possible. And we want representation from every nook and corner of the city to calculate the air quality concentrations, and then of course use that to calculate the air quality index, which will spatially and temporally represent what we are seeing in the city. There are thumb rules that can be applied in calculating these requirements. When generally we want to represent all the populated areas, all the industrial areas, and all the background areas. But if we go by a thumb rule, a thumb rule says that any regulatory grade monitor, it will represent pollution measured in a 2-kilometer radius. I mean, it's a thumb rule. It's not really written in stone. I mean, if you place a monitor which is covered by a lot of buildings, then of course the radius kind of comes down. Then you need more monitors to represent that area. But generally speaking, 2-kilometer radius is something that we use as a thumb rule. And if you have a city of 20 by 20 kilometers, then you will definitely need 25 stations, one in each of these grids to represent the air quality. But then it means when you higher costs, higher maintenance work, and higher effort in reporting and archiving this information and using that for PR. So you pick and choose representative locations within the city domain and use that for further analysis. So but the simple answer is as many as possible, but there are thumb rules that one can apply. In case of India, this is a set of equations that I use to find out what is the representative size of monitors for each of the different pollutants. Generally, particulate matter is often exceeds most of the criteria available in the regulation, so you definitely need more number of stations to measure PM 2.5 than, let's say, CO or ozone, which are much more evenly spread in a city or regional environment. This is an example for a case of Bangalore, where we used zonal population data and commercial and urban activities data to calculate how many monitors are required in the city's airshed. So total of 27 stations are required in the main urban area with the 9 zones, and then 5 in the immediate vicinity of the main urban area to represent the peripheral activities, and about 7 stations in outside the peri-urban area to represent the background concentrations. A total of 41 stations are required to measure and report what kind of air quality that we see in Bangalore. And this will definitely change if we start focusing on a more smaller area. Then you will need more hyper local concentration measurements to represent the situation. What's the difference between hourly and daily air quality index? Air quality index is not calculated on hourly or daily value. It basically says air quality of the day. If this air quality is reported every hour, then it is an index value based on average of last 24 hours or last 8 hours of concentrations data. The 24 hours data is for these pollutants, PM2.5, PM10, NO2, SO2, and ammonia, which have standards defined around a 24-hour cycle. And for pollutants like CO and ozone, these their standards are defined on an 8-hour basis. So you basically use the 8-hour value to calculate air quality index. And if we are reporting air quality index only once a day, then it is an index value based on the last 24-hour average, the last day's 24-hour average, or daytime 8-hour average concentrations for CO and ozone. So there is no as such an hourly or daily AQI. There is only air quality index for the day. What's the meaning of AQI 500 and AQI 999? Again, this is a very artificial cap that was introduced in air quality index. Some countries use it. Some countries use 500 as their cap, and some countries use 999 as their cap. But the important thing is, once you get into the dark brown or dark maroon or these purple zones of any of the air quality indexes, the pollution is bad. I mean, it doesn't mean that only when it reaches 500 it's bad, but anytime you are in that the last category, I mean, it's an emergency. Is PM 2.5 the most harmful of all air pollutants? It is, definitely is. It's mainly because it has a lot more correlations to different health impacts, but it also is a component which has contributions from all the other pollutants that we measure and experience in our atmosphere. So, for example, even though PM 2.5 or PM10, we treat it as one pollutant, it has chemical nature of it is coming from all the different categories that we can think of. When you have the main aerosol categories like crustal, this is dust, metals, black carbon, organic carbon, they're already in aerosol form, so they're immediately part of your PM 2.5. But there is also a lot of contributions coming from the gases. Volatile organic compounds interact with NOx and ozone, and they form secondary organic aerosols. SO2 undergoes a series of reactions depending on the hydroxy and ozone and other VOCs present in the air, and they form sulfates. NOx, again, they react with VOCs and ozone and eventually form nitrates, which are in the particulate form. Ammonia also reacts with SO2 and NOx. They form ammonium aerosols. So these are all in the aerosol form, but the original form is actually gases. So these secondary reactions also contribute significantly to PM 2.5. So when we talk about PM 2.5 as a health indicator, it has contributions from all the other pollutants as well, and it is a very integral pollutant that can be used as an indicator for a number of activities, both chemically and from a health perspective. So for that reason, we consider PM 2.5 as one of the main pollutants for health calculations. Where can we access real-time updates on air quality index? Again, this is a huge question often asked, and there's a lot of information portals. There are a number of information portals available online where you can access. Some where you can download the information directly as air quality. This is an example, openaq.org, and then you can apply any of the equations and you can calculate the air quality index. There's another one called worldairqualityindex.info. They pre-calculate air quality index and post it. So they don't have any raw information on the air quality concentrations themselves, and they use a combination of, I think, both monitoring and some model information. There's another one called IQ Air. They also post a combination of both concentrations and air quality index values, combining both monitoring and modeling data. There are this is a purple air. This is a sensor, not a regulatory grade monitoring system, and they also post both direct air quality measurements and a air quality index. You can pick and choose which air quality index that you want to, methodology you want to use. You want to use US or EU or Singapore or any other. So this video provides a quick overview of frequently asked questions on air quality index, and you can find a lot more on this topic on our working paper series. Thank you.